Hello, and welcome to this talk, Starship, a $2,000 ride to orbit. And I've been seeing lots of discussions about how much it might actually cost to go into space on Starship. There have been some high estimates, and then there have been some pretty low estimates. So I thought it might be interesting to approach this from a modeling perspective, based on some information we know, or at least some information we can guess at, and try to come up with a decent estimate, or at least a better idea, of what flying into orbit on Starship might cost. And to start, I need to back away a little bit, and I'm going to talk about how airline financials normally work, because the whole talk about Starship is that it will be capable of being operated much more like an airline and much less like a rocket launcher. So we're going to start our own small commuter airline. I've chosen a plane. This is a 2018 Cessna Caravan 208. It holds 8 passengers. And when we start looking at the financials for this, we need to understand that there are 2 different kinds of costs in this sort of business. There are fixed costs, and the obvious one is we buy the plane. It's about a $2 million plane used. Usually planes are depreciated over 15 years, which means as a business you can think of taking that cost in 15 chunks. So that's about $130,000 per year, at least for this used version. Crew, this has a single pilot. It's about $78,000 a year. I'm ignoring the fact that pilots actually don't usually get salary. They get paid per hour. I'm also ignoring all of the ground people that we would need as well for this. So think of that as kind of just this lump number there. We have hangar cost. We have insurance cost. The important part about fixed costs is that we pay for them whether we fly or we don't fly. So that's what fixed means. So it's about $250,000 a year for this sort of plane. Variable costs, well, those are the opposite of fixed ones. Those are the ones that we pay based upon how much we fly. So fuel for this plane is about $300 an hour. Maintenance is about $59 an hour. Then we have this weird thing called engine reserves. And maintenance for airplanes that carry people, especially that carry commercial passengers, is very, very strict. And you have specific requirements to perform a specific level of maintenance periodically based on how many hours you've flown. So that maintenance can be pretty pricey. So you can think of this engine reserve account is just a way of allocating those periodic big expenses to a per hour basis. So if we look at the cost of those maintenance and we divide them by how often they occur in terms of hours, we get something like this. So it's about $500 an hour to fly this plane. So now we know some costs, and let's start, and we're going to start with just this very, very small thing. Twice a month, we're going to fly football fans 300 miles to a football game, and then we'll fly them back. So we'll do that twice a month. So 2 hours per flight, we fly 4 times, 4 legs per month, or 8 hours. So the fixed costs, we take the $250,000, divide it by 12. Our cost per month is about $20,000 or $21,000. The variable cost for the month is about $4,000. So total monthly cost about $25,000, and we flew 32 passengers. So 8 passengers on each of those 4 legs. So the cost per passenger is nearly $800. And if we look at that, it seems unlikely that many people are going to want to pay $800 to fly just 300 miles and then another $800 to fly back. And what's the problem here? Well, just looking at the numbers we have here, clearly it's that fixed cost that's killing us. And I did a little graph to make this a little more obvious. So on the left side, we see if we fly twice a month, about $800 per passenger. And then as we start flying more days per month, what happens is those fixed costs get allocated across more flying days. So, and what will happen as we fly more, the fixed costs get much smaller and we get close to the incremental costs. So, since we're trying to do that airline-like cost model for Starship, let's look at what those financials might look like. And putting this model together was complicated. There are a whole bunch of things that could feed into Starship per flight costs, and many of them are not known very well. We only have estimates, and some of the estimates are probably pretty bad. So, what did I look at? So, how much it costs per year to own Starship, and when I say Starship here, I'm meaning both Starship and Super Heavy. It would be possible to do analysis of the two vehicles, the two stages separately. That would make things much more complicated, and I don't think the results would be much better, so I decided not to do that. The cost of the ground equipment, the launch pads, the towers, everything like that. Variable cost per flight, the number of active vehicles we have in our fleet, and the flight rate. So how often we fly each of those vehicles. As I said, there's lots of unknowns in this, and because of that, because we don't have real numbers, I took an approach called low, medium, high. And basically what I'm going to do is I'm going to put a number that I think is a low estimate, one that I think is a medium, and one that I think is a high estimate. And then we're going to play around with those and see what we can learn based upon that. So starting with vehicle cost per year, this obviously depends upon two big factors. The first is the purchase price. How much does it cost to buy a Starship Super Heavy pair? And the numbers I put on that, 50, 75, and 100 million. Those don't seem unreasonable. Might be more, might be less, but that's probably the right ballpark. For the lifetime, this is much harder because we simply have no experience on lifetime of reusable rockets. We know what SpaceX has done with the Falcon 9 first stage, and we know that they've flown them maybe 10 times. If you were going to fly one of these for 15 years, you need a totally different level of vehicle to be able to do that. So, not having great answers here, I arbitrarily picked numbers that would kind of make sense if we're talking about something similar to an airplane. So, 5 years all the way up to 15 years. Now, obviously, whether Starship can really operate like an airplane in terms of how often it flies and how much maintenance it needs are factors that we really don't know yet. So anyway, putting those together, we get anywhere from a low number of about 3.3 million per year, all the way up to a high number of about 20 million per year. The next cost is the cost of ground equipment, and this is a challenge. In airline operations, you would have a spaceport, or you'd have an airport, and somebody builds the airport, and then they charge per flight costs. So for example, if you're going to fly a 737-700 to LAX and you want to land, it costs you about $1,800 to land. And in addition, you'll get charged a cost if you want to park and store the plane there. You'll get charged a cost if you actually want to use one of the passenger gates. And so it's all fee-based, and it all ends up being variable costs. Now, $1,800 doesn't seem like much for a 737-700, although a normal flight for that might only be $50,000. The interesting thing is, LAX brings in somewhere in excess of $1.2 billion per year just in landing fees. It's simply because they have 600,000 landings per year. That sort of approach doesn't apply to Starship, at least in any credible short time frame. The other problem with that sort of model is airplanes all share the same infrastructure. They need the same fuel. They can all use the same airport. They can all use the same landing and parking. They can mostly use the same terminals, the same gates. So that allows things to just be very simple. That's not true from rockets. So every rocket is very likely to need its own specific ground support equipment. So there's a special launch pad for Starship Super Heavy. There's a special launch tower for that. And there is special dedicated ground source equipment. So the only way I can think of dealing with this is treat it as a big capital expense rather than a fee. I don't have great numbers for this, and because I don't have great numbers, I have no idea what low, medium, and high should be, so I'm only going to pick one number here, and will simplify the model a little bit. So I'm going to assume that this ground infrastructure costs $1 billion, and that it's depreciated over 30 years. And 30 years would be pretty typical for things like factories and buildings and those sort of things. So that would be about $33 million per year. It could easily be a lot more if you think the costs are a lot more to build something like this, or if you think that you're going to have to revise it more often. Variable cost per flight. This includes fuel plus maintenance. So I threw some arbitrary numbers here. We've seen some stuff that suggests that Musk thinks that fuel costs are $800,000 or $900,000. He's talked about variable costs before. We really don't know what maintenance costs are going to be, and they're bundled in here. So once again, I picked low, 400,000, which is probably the low end for fuel, medium 800,000, and high $1 million too. If Starship is like an airline, in that you don't have to do a lot of maintenance, then it could easily be medium or low. If you need to do a lot of maintenance, it could be much more than this. Active vehicles, 1, 10, or 100. That seemed pretty straightforward. Flight rate, 10 times a year for each vehicle, 100 times a year, or 1,000 times a year. Also pretty straightforward. So what results did I get? Well, I built myself this big model in Excel that did a permutation across all of those. And it was either 81 different combinations or 273, I think. I did some math. This is a correlation across. So basically what I was looking for is the cheapest, looking for cost of flight and what factors most influence it. And the result is really not very surprising. The biggest effect on cost of flight is two things. First, there's the active vehicles. And active vehicles are really important because that controls how much you spread the launch cost over a whole number of vehicles. So if you have one vehicle, that launch cost per year is only going to be spread over that one vehicle. If you have 100 vehicles, it's going to be spread over that 100 vehicles. So not surprisingly, that has a big effect. The second is the flight rate per year, which also makes a lot of sense. And it also, the ground support equipment gets spread apart more on flight rate. And then also the cost of the vehicle gets spread more on flight rate. So we have a cost of the vehicle per year. And if we fly one time, obviously it's not very good. If we flew 100 times, it would be much better. So I did a lot of math here to kind of come to a conclusion that I probably already knew. But that let me do a little graph here. And what do I see? Well, basically looking at the variables that are important if we had one vehicle and we flew it one flight a year, it'd be somewhere in the order of $42 million per flight. And that seems actually pretty reasonable. Even if you have a reusable vehicle, even if you fly it very rarely, as long as it's a reusable vehicle, it can be relatively inexpensive. And 42,000 for something with Starship's payload would be pretty cheap. But notice what happens if we step over to the right and we look at 10 flights per year. And 10 flights per year, we spread out the cost much more, and we get down to about a $5 million flight. And I was kind of surprised to see $5 million as not being terribly unrealistic for a single vehicle if you fly 10 times a year. And wow, that's a small one. Now, obviously, this is going to depend on those variable costs. Once we start getting to 10 flights a year, we're getting close to variable costs. So this is all on the orange, and then you notice if we move over to 100 flights a year, it goes down to about maybe 2 million. And I have the other parts, the other lines here for 10 vehicles or 100 vehicles. And notice that if we get to 10 flights a year, it really doesn't make that much difference. Okay, it's a difference between 5 million and maybe 2 million. And that was kind of surprising. So having a lot of extra vehicles really doesn't cut down your costs as much as I would expect. And part of that is because the ground support equipment really isn't that expensive in the choice I made. Now, if my choice was wrong there, if the ground support equipment was much more expensive, the effect there would be greater. So, what does this really mean? Well, I've said that it looks credible that you could get a per flight cost down to 5 million, maybe down to 2 million if you push more than that. So what does that really mean? Well, it really means the cost of tickets is really about passenger count. So, what's a credible passenger count for Starship? And I decided to look at this a few different ways. So first, I was looking purely at volume. So the payload volume of Starship is about 1,100 meters cubed. Interestingly, if you look at the Airbus 380, they actually have a cargo version. And when you have a cargo version, the volume in the hold is 1,134 meters cubic meters. So virtually the same. So an A380 passenger version can hold a maximum of 853 passengers in what they call a one-class configuration. I would call that a cattle car configuration. All economy seats really tightly together. And they say 535 passengers in a comfortable three-class configuration. So based on this and on the fact that we actually need volume for life support and other things that airplanes don't really need to have, I'm saying 500 seems like a upper bound in terms of volume. When we look at mass, so assuming passenger mass of 90 kilograms, that may be a little much. Seat mass of about 35 kilogram, which is about what airline seats weigh. You can think of spacecraft seats probably need to be beefier than that. Consumables mass of about 12 kilograms, that puts us up to about 137 kilograms total, or about 300 pounds. So hey, Starship payload, the goal is 150,000 kilograms. I'm going to say that you're going to spend a third of that, 50,000 kilograms, for structure, life support equipment, and everything else. That gives us 100 kilograms left, and if we divide that by 137 kilograms per total, we get 729 passengers. So that's really kind of in the same ballpark as 500. What about risk and exposure? Well, this is an interesting one. Consider these two scenarios. The first one is you have a vehicle, you fly 50 flights per year with 10 people per flight. Or you have one flight per year with 500 people per flight. Option 1 has much less risk and much less exposure. The first reason is if you are flying once a week, you can end up with an operations crew that has a nice cadence and they are doing the same things over and over and over and over again. And that is how you get high quality operations. If you have cases where you are doing things once a year only, you need big checklists and you need very strict quality control and lots of careful attention, simply because people are not used to what they are doing because they aren't doing it very often. And this is one of the reasons current launch systems are very expensive. The second very obvious thing is that with option 1, you have a far smaller number of people at risk per flight. So if you just think of this from a PR perspective, which is not really the only perspective, but it's one, the bad PR, if you fly 49 times and you happen to have an issue and a few people die, is very, very different than a world in which you fly and 500 people die. The other really important thing from a risk perspective is that if you are flying 50 flights per year, you are getting a lot of flight experience. So you do need to carry insurance for these sort of things. Your insurance costs will be much lower for an option where you carry fewer people and fly more often. So having looked at all of that, all of those are interesting concerns. So based on some costs per flight and passengers, well, this is really very simple math. If your flights are $5 million, you have 10 passengers, it's a $500,000 ticket, all the way down to if your cost per flight is $1 million and you have $500 passengers, the cost per passenger is about $2,000. So higher passenger counts appear when you get to high flight rates. And what I mean by this is there's no way that SpaceX is going to start off early in the program and try to fly 500 or even 100 people. There's just very little margin in it for them. The prices here are low enough. Excuse me. The prices here are low enough that it's not going to matter. And that takes me to the final thing I want to talk about, which is price versus cost. And there's been pretty much everybody I've seen who has talked about cost has assumed that price is the same thing. So they've assumed that if SpaceX has a cost of $2,000 per person to orbit, that they will be able to buy a ticket for $2,000 per person per orbit. Now, if we look at airlines, airlines are a very, very competitive business. And airline profits run somewhere in the 10% range or even only the 5% range. So what that means is the price is not very different than the cost, or not much more. But with Starship, assuming everything works out the way we expect, SpaceX has incredible pricing power with Starship flights to orbit. Simply because there's no real competition and they can charge what they want. So current cost on Dragon of flying a person into space is probably somewhere around $40 to $50 million. What that means is SpaceX could easily charge more. Now, will they charge 2 times their cost? Will they charge 5 times their cost? Or will they charge 15 times their cost? I do not know, but I suspect they will not be quickly trying to get into a race to the bottom. There's simply no reason for them to forego the money they can get with higher prices. Now, This all does depend on how SpaceX views the market. And the real question here is whether they think, or to what extent they think, lowering price will lead to increased demand. So, to put it pretty simply, if they cut their price in half, would the number of people who want to buy tickets or able to buy tickets go up more than 100%? Would it more than double? If it did, then it might be in their financial interest to do that. But remember, it still needs to make sense kind of from a risk exposure perspective. So when I look at all of this together, looked at all these numbers, I did come up with one number that said $2,000 per flight seemed possible. I really think it's far-fetched. I don't see a world in which SpaceX in the near future, and by near future I mean even the next 10 years, is going to want to put a ton of people on a Starship. And even if they do, I don't think they are going to be charging anywhere close to their costs. I think they are going to be trying to accumulate money that they can use to build a whole bunch of Starships, both to expand their fleet for this sort of thing, to do things on Mars, and to maybe do point-to-point travel on Earth. And point-to-point travel is a totally different topic, and the financials would be very different for that. So $2,000 a flight, that just seems far-fetched to me. But kind of surprisingly to me, $10,000 a flight actually looks like it might be possible. If Starship, or whatever follows Starship, ends up being like an airplane, I can see a world in which you have a single launcher or a booster and a Starship, and you fly them a lot. And if you fly them a lot, you can get pretty close to your variable costs. And it actually turns out that liquid oxygen isn't that expensive, and liquid methane probably isn't terribly expensive there either. So there are probably some decent ways that they can reduce their fuel cost, and as long as their maintenance is low, that might actually be possible. So that's all I wanted to talk about here. Thanks for your attention, and please subscribe.